This glowing structure represents a standard large language model. It contains vast knowledge, but being physically isolated, it lacks the agency to act. By connecting that isolated brain to external tools, we create a hybrid AI agent that moves past simple text generation and begins interacting with its environment. To build this, you need a basic familiarity with Python, your preferred code editor, and API keys for both a language model and a web service. Linking conversational AI to functional tool use allows you to run an agent that executes tasks on your local hardware rather than just describing them. Step 1 is establishing your local development environment, which is where you will write and execute the code. Open your code editor and create a dedicated Python file. In the same directory, create a new folder specifically named Sandbox. Before we write any logic, we must address the primary failure point of local AI agents, the risk of unconstrained file access. Language models can occasionally hallucinate. If given broad permissions, an agent might accidentally overwrite critical system files or create thousands of junk documents in a loop. Looking at this security layout, the solution is to hard code a specific directory path. This physically isolates the agent's operations within that sandbox folder, keeping it separate from the rest of your operating system. Establishing these strict security boundaries is a mandatory safety measure before you grant an AI the power to manipulate your local hard drive. Now, transition to your code editor to begin the initialization phase of our script. First, import the LangChain framework and instantiate your core language model. Next, initialize a built-in search tool, like Tavily Search. This gives the agent its ability to query the live web. This flowchart illustrates what a tool actually is in this context. It is a standard programming function that the LLM is explicitly permitted to trigger by outputting a structured JSON request. Before running the code, verify that your environment variables and API keys are loaded. Missing keys are the most common cause of errors at this stage. By integrating these specific toolsets, your LLM shifts from a closed-loop system into an active participant on the live internet. With web access ready, we shift back to the local system. The agent needs a way to extract that web data and physically store it. Write a custom Python function designed exclusively to save text. Hard-code this function so it is only capable of writing to your sandbox folder. Then wrap this custom function in a tool decorator. This ensures the framework recognizes your code as an executable action the agent can choose. The AI relies entirely on the function's docstring to understand what that code does. Here, you can see how the LLM parses the docstring text. It uses these written instructions to determine the exact conditions required to trigger this specific file-saving function. That resulting JSON output flows back into your Python script to successfully execute the physical file save. Providing explicit, well-documented functions is what allows the AI to manipulate local files based on its own deductive reasoning. With the tools built, we can assemble the final components and prepare the script for its first live run. We bind the model and the tools together using the REACT methodology. REACT stands for Reason and Act. It serves as the logic engine governing the agent's behavior. Write a prompt assigning a specific task to the agent. Instruct it to research recent AI news and save a formatted summary to your local drive. Execute the script in your terminal. You will see a slight processing delay while the API connects. Wait for the output to begin. Watch the agent's internal monologue. It formulates a thought to search the web, takes action using Tavily, and observes the incoming data. The loop cycles a second time. The agent processes that observation, decides to save the data, and triggers your local saving tool. By forcing the agent to continuously verify its observations against the original goal, the REACT framework prevents it from getting stuck in an infinite loop. The terminal execution is finished, so let's transition back to your local file explorer. Inside your sandbox directory, you'll find a newly generated text file containing the formatted AI research. This file confirms your success. As illustrated here, you have engineered a system capable of bridging live internet research with local file manipulation. The next step is to implement Retrieval Augmented Generation, or RAG. This will allow your agent to read your existing local PDFs to gather context before it searches the web. Building systems that navigate web data and local files provides a foundation for complex personal automation. Just remember the mandatory rule for local agents: keep their write access strictly sandboxed.